So, what we need to do is we need to prepare our brains to go back into interval land because we've been living in test land for a while. So, to review for your test next week, in the state for a test, you do null hypothesis, alternative hypothesis, define the parameter. We're not doing that in this. Don't write it. Define the parameter and whatever the alpha level is, just make sure that you state it if it's not stated. So that should be what you're kind of used to for the chapter. And now we need to take our brains back to chapter 8 for how do we start a confidence interval? Does anybody remember how to start it? That's the start of the plan.
Yeah.
Yes, beautiful. Okay, so we're gonna say for whatever percent confidence interval for, okay, and in chapter 8, we said P equals the true proportion. In chapter 10, we say mu equals the true mean blank I'm just going to say in context, meaning that you have to put something about that particular problem. So the language from that problem, usually you can just copy straight off of the problem. Okay. Now, plan. We're going to start there. We say what we're doing. One sample T interval for means. One sample T interval for means. And yesterday we learned about why it's T and not Z. And the reason that it's T, just to remind you, is because we will not have sigma. And when we don't have sigma, we have S of X instead. And so we're not allowed to use C. Did anybody hear what I said? I highly suspect that anyone heard what I said. We'll see. Okay. I do know, you know the answer to the next question. What are the conditions? Random. I can't even spell random. Random. 10% is your usual, unless you have random assignment, then you get to skip it. What's the last one? Okay. Great job. So you answered my next question. Large counts is not going to be n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10 because there's no p's. So you have n is greater than or equal to 30. So CLT applies. Or graph, yep, shows no extreme skew or outliers. Okay, I'm going to ask a really, it's going to seem like a completely off topic question. Does anybody remember? Okay, we don't really have commercials anymore that much. Does anybody remember the commercials for like the monster truck jam?
Yeah, so where they have the really big lifted truck.
Yes, yes. Okay, do you remember the commercials for that?
Yeah, really.
Yeah, they'd scream like, you know, extreme like that. Okay, so when you're looking for skew or outliers in one of your graphs, it's gonna have to be really, really bad. to violate the condition. There are some in this book and in the AP problems where I'm like, I don't know about this, that looks pretty skewed, or I see an outlier. And the book and College Board is just like, not extreme. So anyway, when I read this, I read to myself, no extreme skew or outliers. It's gotta be really extreme for it to not pass the condition. Like really bad. Like extreme. So now I've ruined the word for you, but anyway, whatever I can do to make you remember. There really are gonna be some where you're gonna question it and then, okay. So the do is the confidence interval, and that is statistic plus or minus T star this time times the sample standard deviation over the square root of A. And do you guys remember what the statistic is? Anybody remember? Yeah, sample mean. So X bar plus or minus T star Are you guys laughing at my shirt? Yeah, I know. The fact that Mr. Tyler wouldn't buy the other one. Nope. He's like, no, he actually considered it, but it was so cold out that he was like,
Okay.
no one's ever gonna see it. Yeah. Anyway, okay. Conclude, we are blank % confident So we are blank % confident that the interval of blank to blank captures the true mean context. Okay, now in your mind, before I taught this just now, how much of this did you already know? Like, yeah, like almost all of it. And so I want you guys to be, this is going to sound cheesy, but increasing your confidence in these because they're kind of repetitive. Like, and repetitive is good in this case because we know what to do. Oh yeah, your whole table left those on the table. Yeah, the whole rest of your table left those on the table.
Not in fact, I mean, we all left it.
Yeah, in a pile,
Where did we leave it?
right on the table.
desk.
I put them back over in the shelf thing.
Yeah, I got it. Don't give me what? Like all of us did? Yeah.
Oh, the whole table.
What?
Oh, maybe not Bryce. He said there was 4 of them over there.
I got one.
Oh, it was funny. I was cleaning up everything. I was like, wait, they just left these.
If it's not in the model, it'd be great. Yeah,
A lot of them.
there's a lot.
Quick random question that has nothing to do with that. Are any of the glue sticks about to die in any of the wreckage? Just like that.
Yeah, you still keeping on? I mean, I'll do this first.
I have a lot of them.
Wait, I'm
Pretty well.
There, so for yours. I thought. Oh, we would actually. You know what that is? You can smell. Yeah, how many?
I just didn't really realize it took this long to cut out a thing. Oh, yeah. No,
Yeah.
like for good after that or just?
Yeah, I just said.
Yeah, but sometimes we can ditch them for certain things.
They don't, they like, yeah, they have like avocado toast.
Do they have like scrambled eggs and, yeah, I try to do that for like keto purposes, like scrambled eggs and bacon and,
And I think that's.
yeah, and sometimes I accidentally eat the potatoes. Not supposed to. Okay. I think that was plenty of time. I'm not really sure what's happening. Oh, I see that my supplies are being used for good reasons. Okay. Alrighty. Example. A 2016 Pew Research study, by the way, this is a real research firm. Study interviewed a random sample of 1,520 American adults and found the average number of books they reported reading was, for some reason, the eyebrows are really, really high on this X bar. I'm not sure why, but X bar equals 12 books with a standard deviation of S sub X equals 18 books in the last 12 months. Construct and interpret a 95% confidence interval. Okay, so we're start that state, 95% confidence interval for mu equals the true mean. Okay, now where should I pick up the wording from the problem? What should be the next word? Number, great. Then my little brain goes, do you have to read them or do audiobooks count? Okay, now you guys know where this is going. We already talked about this yesterday. There will be a 2 sample. So the next thing you would do if you got this FRQ would be like, is it 1 sample or 2 sample? This one's 1 sample. Okay. Random, indeed, random sample. 10%. Okay, do I need to do the 10% condition here? Yes. And there are some people who put does not apply on the test, but I didn't have an experiment on there, so be very careful. It needs to say assignment.
You're doing 10%. I like it.
Uh, that's a really good question. I don't think so, but it doesn't, once you do it, start writing it for an experiment, it doesn't make sense. Yeah. You get halfway in and then you're like, wait, yeah, it just doesn't make sense. But anyway, okay, now another picky point here. Some kids on the test went too far with what they were putting in the 10% condition. This should match whatever the sample was of. So if the sample is of American adults, don't put 10% of all American adults who read books in the last 12 months. You don't know how many that is. That's the whole purpose of the math problem. Okay. Oh, 1520 is well above. Okay, now it's the first time that we touch a calculator in a math problem. So statistic, what is the statistic from this problem? Well, plus or minus. Oh no, I've got to find T star. Okay, so I'm going to come over here into what is the degrees of freedom?
Oh, this one. Oh, okay. Oh, you can argue? Oh, so- oh, 15, 20 minutes.
Okay, make sure you know how to do this. It would be really embarrassing for you if you asked me for help on the test. Oh, why did that happen before? Okay. Okay, couple of things. Right here. First, make sure that it's a positive number. C star means absolute value, just like C star should be positive. Second, this is a little misleading because you're like, oh, it's 95% confidence. Does that mean it's 1.96 all the time? No. Now, why is this one really close to Z star for 95%?
Because of numbers.
Because, yeah, there's really, really big sample size. Sample size is 1520, which means that this is almost perfectly normal. And if we wanted to, and we had time and energy, which we don't, we could do normal CBF to see the difference between the two, but I don't want to because it's Friday afternoon and I just can't do it. Okay, but
I agree.
does that make sense why it's so close to the 1.96 you're used to? Just don't assume that they're all the same. They're all different. Guys, this is important. You have to calculate this for every problem. These are not, there's different T star for every sample size. So you can't just be like it's 1.96 or it's 1.645 like we did before. But that's good because that means that we'll have to do it a bunch of times. Okay, anyway, 1.96 times. Okay, and then standard deviation is 18 over the square root of n. Yes, any? How about you write LC on all of your homeworks, but on the test, you actually write large counts? Okay, any questions about this FRQ? It's not, I mean, it's not completely, this part's done. The FRQ itself is done. There's another question after it though. Do you have any questions about this? The procedure, what goes where? Okay. Last bit. Mm-mm. Mhm. Okay. So does your interval provide convincing evidence that the true mean for all American adults is different from 12 books? Just to grab our answer from the previous problem, it was 11.095 to 12.905. I'm going to write it like this just because sometimes that's how it appears. Sometimes the intervals are written with the low and the high looking like a coordinate. It's not a coordinate. It's just the low and the high. Okay. But the question is 12 in the interval? Yes. Okay. So does that mean that 12 it's going to be different from 12? Are we sure that it's different from 12? No. Okay. So we're going to say no. Since 12 is in the interval, since 12 is in the interval, we do not have convincing evidence that the mean is not 12. Yes, honey? Yes. And we're going to do that again when we get to the two sample ones. Okay. So do you guys remember? Of course you do. Those algebra problems that we did back in chapter 8. Let me show you a picture of it. Where this is your chapter 8 notes. We had margin of error is greater than or equal to critical value times standard error. And then we plugged in the stuff and solved for n using algebra. It's in there. It's dusty in your brain, but it's in there somewhere. You did. We did this. Okay. The algebra is actually easier, but I want to point out that we did write on our yellow sheet, you should all have that this part of the formula is margin of error. So if you don't have that, that's something you're allowed to have right there. So margin of error is whatever's after the plus or minus part. Okay, so for us, we're gonna flip back here. When we're working with means, it looks a little different. So we have margin of error, and then we want that to be less than or equal to. Okay, and the critical value for this is not Z star, it's T star. And the standard error is S sub x over the square root of n. Okay, and all you're gonna have to do is put T star here, S sub x here, margin of error here, and solve for n algebraically. It's much easier than the other one. So divide by T star first. Do you want to do one? No? Okay. Oh, I don't have one for you. I just wasn't sure if you actually wanted to do it. No,
Guys, we're gonna fix that. Then we get the idea. Toby said no.
it's really not bad, I promise. It's just solving for
Guys,
X.
what does it do?
No, I really don't have one made up. Like, I don't even have one. I just wanted to tell you that the margin of error looks a little different for means. It's just the second half of the interval for means instead of proportions. That's all I wanted to say. I'm good. Okay, do you want to see my joke though?
Yeah.
Okay.
We're back. Know my name? I get you.
It's just supposed to be, it's supposed to be like this guy's hitting on you in a dumb way. It's in like a nerdy way. What are you doing? Jamie, I thought you'd like my joke. I mean, if you ever meet a cute girl, you could say, you know,
Should I use that one?
have you ever?
Should I add that to the bag shop?
Yeah, I think you should. And then you should let me know how it goes.
Should I do cold calls with this? This ad group chat?
Oh my God, that'd be hilarious.
No.
Probably not good.
Hey, put that right down. I'll still be doing the cold call. Right?